Okay, today we get to start our exciting excursion into the world of trigonometry. Now, the word sounds really scary, but really you're going to find it's not so bad. The first thing we got to kind of get down before we can get any definitions, and we talk about tangent ratio, but we need to talk about the ideas of opposite, adjacent, and hypotenuse in a right triangle. Now, hypotenuse in a right triangle, I'm just going to put a new page in here for a second. Hypotenuse in a right triangle is a pretty simple concept, because we all know what a hypotenuse is. The hypotenuse is the side that's across in the right angle. It is the longest side of the triangle. It only applies to right triangles. We're only going to be doing trig with right triangles. So every triangle is going to have a hypotenuse. So segment AB here is very clearly the hypotenuse of the triangle. It's the longest side. It's always a hypotenuse. It never changes. The other two names are dependent descriptions. It's kind of like right and left. Right and left kind of depends on your point of view. If two people are facing each other directly, and one of them and we say point right, you're going to point in opposite directions, because what is one person's right is the other person's left when they're facing each other like that. It's a relative description. And the terms opposite and adjacent sides are relative descriptions for the acute angles of a right triangle, okay? So opposite and adjacent only apply to acute angles. We don't talk about opposite and adjacent of the right angle in a right triangle. The only thing we talk about with that is the hypotenuse. All right? Now, the term opposite is very, very descriptive. If I want to talk about the side opposite of angle B, this is the side opposite angle B. If I want to talk about the side opposite angle A, then this is the side opposite angle A. The term adjacent is also kind of descriptive. If it's not the opposite side and it's not the hypotenuse, then it's the adjacent side. So this is the side adjacent for angle B, and this side would be considered adjacent for angle A. So basically, we always have to, whenever we're doing a trig function, whether it's tangent, which we're going to learn about today, or sine and cosine, which we'll learn about later on, we always have to establish a frame of reference before we can even begin. And the frame of reference is one of our angles. So I'm either going to be talking about angle A or angle B, one of our acute angles. If I'm talking about angle B, if this is my frame of reference, then, sorry, I shouldn't have done that in red because I'd always been doing the A stuff in red, so let me undo that real quick. We're going to talk about angle B, which I'll do in green to keep the color coding straight. Okay, if angle B is my point of reference, and sometimes I'm actually going to draw a little person there to indicate to me that's where I'm standing, that's my point of reference. Then I can very quickly identify which side is the opposite side. Oh, AC is the opposite side. Which side is the hypotenuse? That's clear, it never changes. And so I can tell also which side is the adjacent side. My point of reference is angle A. Then the opposite side is CB, and the adjacent side is AC. So opposite and adjacent switch depending on point of view. Back to our definition. The tangent ratio for a triangle is defined as, and you can see it right here, the length of a leg opposite to angle A over the length of the leg adjacent to angle A. So here, angle A is my reference. I'm standing right here. And the tangent of A is the opposite, length of the opposite over the length of the adjacent. Tangent is a ratio of lengths. So, find the tangent of S and the tangent of R in this triangle. Right, the answer is a fraction and a decimal rounded to 4 places. So it's a little different. We're going to work with fractions and decimals here. We'll get to y in just a little bit, but let's just do it for now. So let's start out with S. I want to find the tangent of S. Okay, so my point of view here is going to be S. Tangent of S is going to be the length of the opposite for S over the adjacent of S. What is opposite of S? Is it the 18, the 80, or the 82? Well, let's identify. If angle S is my point of view, well, 82 is always the hypotenuse. 80 will be the opposite, which means 18 must be the adjacent. So tangent of S is going to be 80 over 18, which we reduce to 40 over 9. And if I get that in a calculator as a decimal, 4.444444. Decimal to 4 places. Okay, it's about equal to that. But what if I want my other perspective? What I want tangent of R? You're saying it's the same triangle. That's true, but it's a different angle. So it's going to be a different thing. Because if R is my point of view, this is still the hypotenuse, but now this becomes the opposite, and this becomes the adjacent for R. So it's going to be the reciprocal of that. It's going to be 18 over 80, or 9 over 40. And 9 divided by 40 is 0.2250. Exactly, to 4 decimal places. Notice using about equal here because I rounded it off. This is an exact value. I mean, it literally is 0.225, nothing after it, but I got to go to 4 decimal places, so I put the 0 in. That's finding a tangent ratio. Your turn. Find the tangent of J and tangent of K. I'll tell you what, for the question, we'll just do tangent K. I'll do tan J for us. So tangent of J, if J is my perspective, is the opposite, which would be 24 over the adjacent, which is 32. 24 over 32 does reduce. 8 goes into there 3 times, 4 times, or 0.7500. Now you find the tangent of K. How do we use the tangent ratio? Well, this is where it's really going to get interesting. Now, instead of having an unknown angle, we have an unknown side. But I have a given angle. The given angle is going to be my point of view. And here's where things get interesting, and you will need a calculator for this that has trig functions on it. What we do is we set up a ratio. The tangent of my given angle, now I know a measure of that angle, tangent of 32 equals the opposite over the adjacent. Now, tangent of 32 has a value. Get out your calculator. You might want to pause for a second while you get out a calculator. But if you get out your calculator and you type in tangent of 32, it gives you a big long decimal value. We're going to round that decimal to 4 places just because that's what we did before. It's 0.6249. So tangent of 32 has a value. It's a constant. It's always 0.6249. The ratio of the opposite over the adjacent for any 32-degree angle is always 0.6249, approximately. Now we just have a very simple equation to solve. Now, when the x is in the denominator like this, it's a little bit of work. I got to multiply both sides by x. So 0.6249x equals 11, and then divide by 0.6249. So x equals 11 over 0.6249. And if I do that, 11 divided by 0.6249, I get 17.6. And usually we'll take these lengths to the nearest tenth. So my unknown side here is 17.6. Last thing I ask myself, does that make sense? Well, if this is 90 and this is 32, this must be 58 degrees. Triangles add up to 180. I know the shortest side has to be opposite the smallest angle. 32 and 11, that goes together. 58 is bigger than 32, so x has to be bigger than 11. 17.6 seems reasonable. And once I know that, I could use Pythagorean theorem to find the third side, couldn't I? Because it's a right triangle. And you're starting to see the power of trigonometry right away here. We can solve right triangles using trigonometry. Use a special right triangle to find the tangent of a 60-degree angle. Oh my, special right triangles. Reviewing already. What do they mean by special right triangles? They mean, let's pull out our 30, 60, 90 triangle. What are the lengths of the sides in a 30, 60, 90 triangle? Well, if you recall, they were n, 2n, and n root 3. Shortest side opposite the smallest angle, largest side is the hypotenuse, middle side there. You're saying, well, great, but I don't know the exact values. Sure, you're right, we don't. But can I find the tangent of the 60? Put our perspective right here. Tangent of 60 will be opposite over adjacent. For a 60-degree angle, the n root 3 is the opposite side. Which is adjacent? Well, 2n's the hypotenuse. It can't be the adjacent. It must be n. And what happens? The n's cancel out. The tangent of 60 equals exactly the square root of 3. Now, not so important right now that we were able to do that, but I tell you something, if you take pre-calculus or trigonometry, that's going to be a huge, huge fact that you're going to want to be able to do. Using our identity triangles in trig becomes very, very important in the more advanced classes. So it's something you want to definitely keep track of. All right, two more quick trig problems. I'll do the first one, and then you do the second one. Again, we're given the angle 61, so that's going to be my perspective. We're going to use a tangent of 61 equals opposite over adjacent. Tangent of 61, let's get an approximation for that to 4 decimal places. Tangent of 61 is 1.8040. And I'm going to shortcut this a little bit. When I have this, I can actually, the result of multiplying both sides by x and dividing by that essentially means we swap these two values. So I'm just going to take a little shortcut here and do 22 divided by 1.8040 and get 12.2 approximately. So I found out this side is about 12.2. All right, your turn to do that with number 4, and then we will see you